So here is the next word problem. So here, this is a vector question. You're going to add these vectors together. So it says find the magnitude and the direction of the resultant vector. So that means you're going to add all the vectors A, B, and C. So vector A has a magnitude of 120 directed at 55 degrees. Vector B has a magnitude of 78 directed at 145 degrees. And vector C has a magnitude of 200 directed at 250 degrees. So go ahead and pause, try to get the magnitude and direction, and once you have the answer, unpause. Alright, so let's just write down the givens. So for vector A has a magnitude of 120, and the direction for vector A is 55. Vector B has a magnitude of 78, and the direction for vector B is 145. Vector C has a magnitude of 200, and the direction for vector C is 250. And so we want to add these vectors together. So what we can do to keep track of everything is to make a table with all your x values here and all your y values there. So first for vector A, the x component is going to be 120 times the cosine of the angle for vector A, 55, and the y component for vector A is going to be 120 times the sine of the angle for vector A, which is 55. For vector B, the x component is going to be 78 multiplied by the cosine of its angle, 145. Vector B's y component is going to be 78 multiplied by the sine of its angle, 145. And vector C, its magnitude is 200 multiplied by the cosine of its angle, which is 245. And the y component for vector C is going to be 200 multiplied by the sine of 245. And you can calculate these numbers. The x component for A is going to be 68.8. The y component for A is going to be 98.3. The x component for B is going to be minus 63.9. The y component for B is going to be 44.7. The x component for C is going to be minus 68.4. And the y component for C is going to be 187.9. And once you have the components, you can add them together to get the total x component. So I'm going to call this, I guess, Rx, which means add the x's together. And that's going to give you minus 63.5 for the total x component. And the total y component is add the y components together. So here, this is going to give you minus 44.9. And now you can get the magnitude. So R is going to be the square root of the x component squared plus the y component squared. And that should come out to be 77.8. Next, let's get the direction. So first, before you get the direction, get the relative angle alpha, which is going to be the inverse tangent of the positive y, so positive 44.9 over the positive x, which is going to be positive 63.5. And that'll give you a reference angle of 35.3 degrees. And you have a negative x component and a negative y component. So that means that the actual angle is going to be 180 plus the reference. So 180 plus 35.3, which will give you a direction of 215.3 degrees. Alright, next let's try this one. This word problem says, how far from a hinge should a force of 120 newtons be applied in order to create a torque of 500 newton meters? So go ahead and pause, try to solve this, and when you're ready, unpause. So let's write down the givens. First, you have 120 newtons is a force, and you have 500 newton meters, which are the units for torque. And so it says how far, so trying to get a distance. Well, let's just do an example to see what's happening. So if you look at the door from the top, this is the hinge, this is the door, and you want to apply a force F to get to create a torque that's going to make this thing rotate. And what it's asking for is how far from the hinge. So that how far is actually the radius. So we're actually trying to find the radius here. So the equation for torque is equal to force multiplied by radius at which you apply the force, and the force has to be perpendicular to the radius. And in this case here, you just plug in. The torque is 500. I'm trying to get the radius. The force is 120. So the radius is going to be 500 divided by 120, which is going to give you 1.47 meters.